Intro Algebra 3-1A. We're now going to start looking at solving equations. We've spent time dealing with what to do when we multiply and divide, add and subtract positive and negative numbers. And now we want to actually take some equations and see if we can use some process to undo what's taking place and solve for the unknown. Solving equations simply means we want to figure out what values could go in for x that would make the equation true. Now, there's certainly multiple methods for doing this. You could use guess and check, although it might take you a while. There's certainly nothing wrong with that method, but if we can figure out a system that works, we might save ourselves some time. So before we get too carried away, let's talk about some of the concepts here. One of them is known as inverse operations. Inverse is kind of a way of saying the undoing of something. All right? If you took multiple steps forward to undo that, you would take those same steps in reverse backwards. So inverse operations are operations that undo each other. All right? Those inverse operations will help us in our quest of isolating. In other words, getting the variable completely alone. If somebody's isolated, it means they're out in the wilderness all by themselves. We want to get the variable on its side by itself. In other words, pretend as if the variable just hasn't showered in 45 years and it stinks ultra bad. All the other numbers and everything would want to get away from it. They'd want to go to the other side of the equal sign to get away from that variable, and that's what we want to do. Figure out ways of getting the variable alone. All right? Solution steps are the transformations that we make when we're using our inverse operations. Each inverse operation that we do is actually considered a solution step. It's a step of the problem. All right? It transforms the equation. It will not change its value. It only changes the appearance of the problem. All right? So each step along the way changes how it looks, but not what the problem is actually equal to. So what is the opposite of multiplication? The opposite of multiplication is division. The opposite of division is multiplication. The opposite of addition is subtraction, and the opposite of subtraction is addition. Each one of these actions over here is an inverse of these actions. If I see multiplication in my problem, I'm going to use division to undo it. Inverse. If I see addition in my problem, I'm going to maybe use subtraction to undo what I have. Inverse operations. Transformations. There are more of these on page 132, but for right now we're just going to basically talk about addition on both sides or subtraction on both sides. All right? Simplifying just means if you have two numbers that you can actually multiply or add together or subtract, that you go ahead and do it. You're not changing the value of the equation. You're not doing stuff on one side or the other. You're just taking two values and putting them together as easy as you can. Interchanging is if you take stuff on one side of the equal sign and you turn the whole equal sign around. So what's on one side now goes to the other, and what's on this side now goes to the other, to the left side. It just alternates sides. Again, doesn't change any of the value at all. And linear equations. This one's sometimes a little complicated because there's more definition than we actually need. But linear, I want you to think about, means line. Linear and line, pretty much the same thing. We're dealing with equations that really produce lines. We're not going to worry about the line portion just yet. But over here, you should have a variable in your equation, and it should be written with the first power. We don't typically write the actual first power. It's not like we would write down x to the first. Usually it's just written x. But what I want you to make sure of is that there's no x squared, there's no x cubed, no x to the fourth. It's just x, or n, or r. Just a variable, no other exponents really shown. It also cannot have the variable in the denominator. In other words, the bottom half of the fraction. It can't have the denominator inside what we would call a radical or a square root sign. So you can't have the variable inside here. And you're not going to have any variables inside absolute value brackets. So if you have any of those situations, you're not dealing with linear. You'd be dealing with something else, quadratics, cubic, whatever. All right? Is subtracting 5 the same as adding negative 5? I think the answer to that is yes. We've spent quite a bit of time saying, okay, if we have x minus 5, that's exactly the same as x plus negative 5. Because we practice changing the subtraction to addition of the opposite. So just keep that in mind. I know a lot of you are going to say, well, why do we have to worry about that? I'm telling you that in the many, many years that I've been messing around with this stuff and the students that have been working with me, you have far fewer chances of making mistakes if you get yourself used to adding the opposite. All right? Because later on there's more negatives involved and people lose track of those negatives very easily if they're not careful. Alright? So let's look at a situation here which I'm going to use as representation of an equation. In this particular case, when you have an equation, you're saying, when you have an equal sign, you're saying that one side of the equation is exactly the same as the other side of the equation. And when things are equal, it means they're balanced. So one side isn't heavier than the other. In order to keep things fair, if I were to take an apple and bring it over here and add it to this side, that would make this side heavier and the scales would tip, no longer be equal. But if I add an apple over here and I'm generous enough to add an apple over here, then things will balance back out and they will become equal again. Alright? If I were to take another apple and give it to this side, or maybe I go to this side and give it over here, well, then that side gets heavier and the scales tip down. They're no longer equal. But to keep things fair, if I come over here and add an apple, they'd go back to being equal. So as long as whatever I do to one side I do to the other, I'll keep things equal. If I start taking apples away, now there's only 3, that side's heavier. So I better take one away from over here to keep them equal. It doesn't matter what I do as long as I'm fair. And everybody wants to be living in a situation where things are fair. Well, be fair to the equations. If you do something on one side of the equal, you got to do it to the other as well. Be fair, keep things balanced. All right?